Hello guys, I hope you all set up you all finish the installation of MeTTa, right? So that's nice. Today we are going to continue our session on how we can write evaluations and equalities, or what we call functions in MeTTa. So just like any other programming function, we have inequalities in MeTTa. So we will see what is MeTTa evaluation means and how we can also write some function today. So in MeTTa we have an expressions. So if that expression is not assigned to anything, it will remain unevaluated. So we have seen that, right? If we call any symbol or any expression, it just return it out itself. So unless it's assigned to something else. So that's what evaluation means. So if we don't explicitly equalize it to something or some value for that expression, when we try to execute an expression, it just return himself without transforming that expression. So whenever we need to reduce one expression or one symbol, we need to have an evaluation, right? So we have to assign it to some values. Then later on, when we try to call that expression or that symbol, it would be evaluated or reduced to something value, another value. So we'll see what that means later on. So this is what evaluation in MeTTa means. So for example, when we see when we call as an expression h, just without assigning to any value to it, it would just print the expression itself, like this one. So but if we define an equality, or if we assign some value to an expression, it will reduce the next time when we call it. So for example, here we are defining an equality with symbol which is equal symbol. Then we have an expression that we need to reduce or we need to transform. Then the next time when we call that expression as defined as this one, then it will reduce whatever stored in this expression. So whenever we call h from now on, if we define like this, it will reduce to hello world. So that's a simple equality and example. So as you can see, h doesn't have any parameter, right? So we just define it as it is here. So whenever we call or whenever we try to evaluate that expression, so it will trigger or evaluate it to a symbol, so like this. So we call such kind of function as nulary functions, because they don't accept any arguments. We will see functions that accept other arguments as well. So whenever we have such kind of definitions, it will get evaluated. So if we don't assign value for a symbol or an expression, so expression is a thing that is expressed as in bracket, right? Anything that we encapsulate in the bracket, it would by default would have a type of an expression, right? So since we have defined an expression to be equals to some kind of reduced expression, whenever we try to call that expression, it will reduce or transform to something else. So that is how we define functions or equalities in MeTTas. So we would start with an equality sign, then we would have the name of the expression, then it will reduce to something that we assign here. So we would see how we can also write that. So just to give you an example of it, so it's better if we see with an example. So for example, if I didn't assign anything for an expression called h, so whenever I'm trying to call this one, it just print it as itself, right? So without any transformation. So let's say let's assign to anything. For example, I can say hello, then whenever I'm trying to execute this one, it would evaluate it like this. Yeah. So as you can see here, it just printed as without reducing it, right? Because I didn't assign any value for the expression hello. But when it comes to defining an expression into something, or if we want to reduce the expression hello to something else, so let's have this. So since I define, I'm going to give it value here, so that it can be evaluated to something else other than itself, right? So I can say that so if I say, or if I assign value for hello as MeTTa trading, whenever I'm the next time I'm trying to call hello, it would evaluate to that reduced value. So as you can see here, when I'm trying to call hello, now it would have the value that I have assigned above. So this is how we assign linear functions. And the next one is, what if we want the functions to have parameters, right? So the last time what we see here was a hello function without any parameter, right? So it doesn't accept anything. Whenever we call that function, it just get reduced to something else. But if we want to have a function that's going to do some operation on the parameter that's passed to it, so here we can see that the function duplicates accepts one parameter. So as the name suggests, duplicates do whatever you give it, it will return to value of it, right? So if we have a duplicate here, so it accepts a parameter. So as we can see last time, there are 4 meta types, right? One of them is variable. So anything that starts with a dollar sign and variable name would have meta type of variable, right? So this thing is called variable. So variable is anything that can store value that's assigned to it, right? So we have x here as a variable name. So anything that I'm going to assign for x, this variable would have a value of that assigned value. So the function here duplicate will accept one parameter, and it would return or reduce to an expression within the value of that 2 parameters that I have given for him. So here we are defining or creating a function that can accept one parameter, then it would return double of the parameter. So this is what duplicates do. So this is a function name definition. So whenever we try to define a function, so we start with an equality sign, then the function name, then if it has a parameter, we will define the number of parameters. For example, if it has 2, we would assign 2 parameters. If it doesn't, we just end up with function name, then the thing that's going to be reduced or transformed other than itself. So here we just say duplicates would accept one parameter, then it will give you like the double of that parameter. So this is how we can create functions in MeTTa. So for example, here we can see that I am passing symbol A for function called duplicates that I define here. So whenever I pass symbol A, it would return or evaluate to double A. So that's what the name suggests, or the functions do. So because I have defined it as such. Then if I pass it, I can pass anything to it. It doesn't say any or specify what kind of parameter I'm going to pass. It can accept a symbol, or it can accept a number or any kind of expression. Then it would return double of that expression. So here I'm passing 1.05 as a number, then it would evaluate to double of this value. This is how function or function with parameters works. So if we test that, so the first thing I'm trying to do is defining the function, right, with equality. So I have this equality sign, then the function name that I want to give for this definition. So I can say D here, and function D accepts parameter, only one parameter, so I can say var here, because variable is anything that starts with dollar sign, right, in any name after that. Then the next parameter, the next expression would hold the value that's going to be reduced, right? So whenever I call D, what am I going to do with that? So I would specify the things that I'm going to do with it. I can say var, right, the parameter that I did accept. So I guess is it from me? Yeah, now it's working. So I have passed one parameter called var, so the thing that I'm going to pass to this function called D, then it's going to be reduced to something, right? So I can specify that in the next expression placeholder, or on the next expression here. So whenever we are trying to define a function, so we have to follow such kind of rule, right? The first thing is starting with an expression, and we start with an equality, so like this. So we start with an equality, then we would have two things, right? We would define two things. The first one is the function name and its parameter. So the first parameter, always equality accepts two values, right? We would say like 1 equals to 2, so we only have two values, right? Always. Just like following that pattern, here we define equality with two parameters. The first thing is defining the function name and its parameter, and the next one is defining what is going to be reduced to, right, other than itself. So let me know if you have questions. I can also go over it. So the first thing is defining function name and its parameter. So here on the first place, I'm going to start with function name. So function name here, and if that function is going to accept a parameter, I would give that, or I would specify how many parameters is going to accept. If it doesn't, I would continue to the body of the function. If it accepts the parameters, I would define the parameters as here if I didn't know what is the parameter is going to be passed, right? Here we have seen that duplicate can accept anything. It can accept a number, it can accept a symbol, it can accept any kind of thing, because I define here as a variable. Variable is, it can hold anything that's going to be assigned on it. So since I don't know what kind of things duplicate accept, I just specify the parameter as variable. But for example here, if I know what kind of parameter is going to be passed, I just specify that parameter. For example, if duplicate, or here the function D is accepting one parameter, if I know that parameter, for example, if it accepts B as parameter, then this thing is going to be a parameter, but a defined parameter, right? So I define it explicitly here because I know that what is going to be passed to D. So next I would return anything. So I would say is B. So if I execute here this one, I didn't call function D, so let's define function D. So let's pass parameter that's going to be accepted by D. So I would see the parameters B here, right? So because I know that what parameter is going to be passed to D, function D. So whenever I call D with that parameter, it would reduce to the things that I have defined here. That's clear, right? So if I call function D without a parameter, since function D is accepting one parameter, whenever I'm trying to call it here, when I'm trying to execute function D, it doesn't going to be reduced as anything, because there is no anything or any function that is defined as D without parameter, right? So it doesn't know what's D, so it just returns itself. That's the behavior of MeTTa. So yeah. Okay. As I was saying earlier, so whenever we are trying to define inequalities or functions, the first thing is to start with an equality symbol, right? So then the function name, then the parameter that it's going to accept, then later on the body of the function. So for those of you who missed the introduction session, so we are seeing how we define equalities in MeTTa, or in what we call evaluations. So an expression or a symbol, if it's defined as it is without inequalities, when we try to call that expression or that symbol, it just returns himself without reducing it, right? So that's what we were seeing. So anything that we define an expression, if we doesn't explicitly define what is going to be that expression is transformed to it, so it would return that symbol or itself. Then we have seen that how we can define function. So this function definition is start with an equality sign. So just like any equalities do, it accepts two values. The first thing is the function name, and the second thing is the value of the function, or the thing that's going to be reduced when we call the function. So here we define a expression h. So an expression h, the next time when I call h, I'm saying that I want h to be reduced to hello world here. So whenever I'm calling h, the next time when I execute h, I want a reduction of to this value, right? So h would be reduced to hello world, or the things that I have defined in this expression. And when I try to call h, it will be evaluated to hello world. And this thing is called null function because it doesn't accept any parameter, right? Whenever I call that unique function name, I would get the things that I've defined here. Is that clear for you guys? If you missed any topic from now on, it would be difficult later on. So let me know, and I'll try to explain it more. So in MeTTa, this is how we define equalities or functions, what we call. So we start with a function. So I was showing you here. So whenever we try to write a function or an equality, we start with an equality symbol inside the parentheses. Then it would accept two values here. So the first thing is the function name, and then the second thing is the thing that the function reduced to, right? So as you were showing on the slides. So the first thing is the function name. So the function name can be one symbol, can be a combination of characters or anything, or can be even another expression. But in the parentheses, I define the function name. Then, if it accepts parameter, I would define the parameters here, right? What kind of parameter or how many number of parameter is a function accepting or expecting. So I define here the parameters, right? For example, if it accepts only one parameter, I would say, for example, x, and this function, whenever I'm trying to call it, it expects one variable, right? Then the next value is the thing that it's going to be reduced to. So whenever I call this function name with this parameter, what am I going to reduce for or transforms to, right? So it's going to be body of the function. So this is the what we call the syntax, or the way how we going to define a function, right? So let me show you what I mean. So as you can see here in the above, I have defined a function called hello, right? Whenever I call hello, it's going to be reduced to meta string, this kind of strings, right? So if I didn't define a function, when I try to call hello, it just return itself, right? Because there is no any transformation I have defined for hello. So when I call hello, it just returns as itself. But if I have defined an equality for it or a function for it, the next time when I call hello, so MeTTa expects to reduce this expression to this string, right? So if I run it again, so I would see the value that I have assigned for hello. That's clear, right? So let me know if you have questions. The next thing is, if I have a parameter defined, so there are two types of parameters. The first one is parameters that I know what kind of parameter it accepts, right? If a function accepts a parameter, and we know what parameter it is, we can explicitly say what it's going to accept, right? For example, if let me define one function here. If a function hello accepts a parameter a always, then it is going to reduce to an expression here, to such kind of expressions that I have just defined here. Whenever I'm trying to call hello with a parameter a, it's going to be reduced to the second one, right? I just called twice. Let me comment this out, not to confuse you guys. So I know the parameter a, so it's going to be reduced to the parameter is a, or the things that I have defined on this expression. What if I say instead of a, what if I say c or any other character? What would be the output? Hello C, right? Any other answers maybe? Is that clear? Yeah, right? So because the function I have defined here accepts or expects parameter called a, right? Whenever I pass another parameter other than a, it would say I didn't know such thing, so I would return the thing itself, right? So if we execute that thing as MeTTa and the function, the file name, it would say I didn't know that expression, so it will just return that expression as it is. without any transformation or reduction. That is clear, right? So this is if I know the parameter, right? So what if we have no idea about the parameters going to be passed for the function? So we need a placeholder for that, right? This is where the variables comes in, right? So let's comment this out, and let's see if I define one function. So when we are defining a function, we start with an equality, then two things. The first one is the function name that we are going to define, and the parameter it accepts. So what if we have a function called duplicate? So duplicate always accepts function parameter with parameter 1, the parameter that I'm giving it as 1. So and as the name suggests, it would return duplicates of the parameter, right? So you can't say anything, you can't specify anything, but let's say it returns twice of the expression I'm going to pass on it, right? So here the duplicate function is expecting one parameter, so it's the same as the above one, as hello was expecting one parameter, but here we were passing a specific value or specific parameter, right? So when it comes to the next one, when we see duplicates, so duplicates can accept any value, right? So any value, we don't know what kind of parameter it's accepting. So let's check if I have passed 4 for the duplicate function, right? So what are you guys going to see after executing this definition or this function, right? Yeah, that's right. So if I execute this file, the duplicate function now returns the thing that I have defined here, right? It was expecting one parameter, then the body says return twice of that parameter, so it's going to be evaluated to such thing. That's clear, right? So I can't define anything that I'm going to pass for duplicates. I can say see here, when we were checking hello, see here, hello function was expecting parameter A, but I have passed parameter C, so it doesn't evaluate it to the body of the function, right? But here the duplicate function is a parameter with one parameter as variable. So when I'm trying to execute any duplicate function with one parameter, it can reduce to the body of the function, right? So if I also execute this function, it would say cc, right? So if we explicitly know what's going to be passed to the function, we should have to specify what is going to be the parameter. If we don't know the parameter of the function, we have to have a placeholder as variable. That's clear, right? So what if the duplicate function accepts 2 parameters? What's going to be changed here? Instead of one parameter, what if it accepts 2 parameters? What would be the definition of the duplicate function? Do you have any guesses? Maybe. So here I have defined a duplicate function only to accept one parameter, right? For example, if I say duplicate CD, so if I say duplicate CD, what's going to be the output of this execution? Since it's not been defined here, right? So duplicate with 2 parameters is not defined in our code base, right? Or in our file here. So whenever I try to execute it here, what would be the output? C? CED, CDD, CCD, or what was your CCD? Okay. What else? The name itself, right? Exactly. So why? As you can see here, guys, if whenever I'm trying to execute the thing that is not explicitly defined in the file, so it's going to return itself, right? So here I was defining hello with a specific or explicit parameter called a, but now I was calling hello with different parameter. So it doesn't know this kind of definition, right? So it just returns it itself. So whenever you are trying to execute an expression, anything that is wrapped in a parenthesis is called expression, the things that we have seen in the previous sessions. So whenever we are trying to execute an expression, if first it checks for that value, is it defined in our file or it is not? So if such kind of definition doesn't exist in our file, it just return it as itself, right? So when it comes to this as well, the duplicate CD, it is expecting two parameters, right? It is searching for function called duplicate, but it accepts two parameters. But in our definition, we have only duplicate with one parameter, right? So it would return the reduce of it, but on this case, it doesn't. So it will return, as you can see here, CD, right? Is that clear? Because I don't define function or a definition for duplicates that have two parameters. So to make this thing work, how should I modify the above definition or the above function? How should I modify it to accept two parameters? Now it is only accepting one parameter, right? Exactly. So adding another variable as a placeholder here would solve that issue, right? So whenever I'm trying to call duplicate with two parameters, there should be a definition with the name duplicate that accepts two parameters, right? So I need also placeholder here. That's why it doesn't get evaluated on the first try, right? If I say another variable name, you can say it y, or you can say it anything, then it accepts now two parameters, right? So we have a function name duplicate, then we have one parameter here, and we have the second parameter here. So then it can return just the things that's passed to it, doesn't matter, or we can't say anything when we evaluate the function. So when I try to execute it now, since duplicate with two parameters exist in our definitions, it will evaluate to something to this, right? So what would be the output if I execute this CD, right? Because it is returning, it's accepting x and y parameters, right? Here, or two variables, variable called x and variable called y. Then it's going to return what it accepts, right? So it's going to return the parameter x and y as it is. So it would say CD here, right? Not to confuse you, let me comment this out. So when I run the duplicates now, it would say CD, right? So it's returning the definition of the function. Is that clear? So what if I want to return twice of only the first parameter? That means I'm calling C, right? So what if I want the function to accept two parameters but returning double of the first parameter or double of the second parameter? What's going to be changed in this definition? So function body should be modified, right? So what should I change here? Exactly. So the thing that we are going to do is it accepts two parameters, but it's going to return twice of the first parameter. We don't care about the second, but it's expecting the second variable, the second parameter, but we are only returning the first twice of the first parameter, right? So the body of the function should be modified to what? Twice of the variable x, right? Is that clear? So whenever so whenever I'm trying to call the function, so it would return cc here, right? So what's get changed? I can define what's going to be transformed, right? Whenever that function called, I can specify to what is going to be transformed or to what is going to be reduced to, right? So we can manipulate what's going to be returned to the function, what's going to be accepted by the function, right? So this is how we define a function with different parameters. Is that clear? So the first time it was accepting one parameter. When I call it with two parameters, it just prints that expression. But when after I define an expression a function that accepts two parameters, it's going to be reduced to the value I have defined in the body of the function. I hope that's clear, right? Are we all on the same page? Anyone have the questions, maybe? So we should proceed, right? Exactly. So we have defined a function x here, so it would return twice of the function. It can accept any kind of symbol or any kind of parameter because I have defined the variable here as a placeholder. So I hope that's clear. So first let me see if you guys are on the same page. So what if we want to define an expression, a function that accepts one parameter and it returns like triplet of that expression. So it accepts, for example, any parameter like x, and it would return a function that has value like this, or return the value that's 3 times of the first parameter, right? So how am I going to define this function? Okay. Exactly. So what he was saying is we would have a function name, then let's say t, and it accepts one parameter, right? So one parameter, then I would define functions, the body of the function as such, right? So the next time when I call function name with parameter like 1, for example, like 1, so to what is going to be reduced? So it will reduce to the body that I have defined here, right? I have defined a function t, it accepts one parameter, so I have defined a function parameter here that it's going to be reduced to the thing I have defined here, right? So the thing that I have defined is to return triplet of that parameter. So it gives me such kind of definition. Exactly right. Nice. So the next thing is what if we pass to a function as some kind of expression, right? We were seeing function accepting a symbol, right? A number or grounded data, which is a number, or a symbol that's a letter, right? So what if it accepts kind of expression? So expression is anything that's being wrapped in parentheses, right? So what if it was expecting such kind of expression? So what's going to be changed? So here we are going to see pattern matching. So on previous sessions we were seeing whenever we try to match from the space, right? So the first thing we define is the pattern, right? So whenever we are trying to query or search in the space the parent of a child, we were defining right the pattern like somebody is a parent of child, right? Such kind of pattern definition would match to how we define in the space. So that's called pattern matching. Pattern matching is the things that we are passing as expression should match to the things that's being expected, right? So here we are defining parameter as an expression. So this parameter has such kind of representation. So the first thing is pair. It doesn't matter what the name is, so don't bother about it. And it has two parameters. So then this swap function accepts a pair of two things, right? Pair of x and y. So this x and y can be symbols, can be letters, as we see, right? Variables can store anything. So then it would return what kind of things? An expression with flips of that parameters, right? As the name suggests, swap accept two things and it return the swap of the parameters, right? So this definition of the parameter should match to such kind of representation, right? If I change the expression, I would show you later on. So it doesn't going to be reduced to something else. So it's explicitly expecting an expression will start with pair and the parameter that we don't care about. Only if it's two parameters, it's okay, right? So because we define variable here. So whenever I call swap with a pair of two arguments or two parameters, it will return the swap of the parameters, right? Keeping the defined pair here. So let's check it. So let me comment this out. And so for defining our function, we start with an equality and we define two values. The first thing is the function name and its parameter. The second one is the return type, right? So let me write the function name. So the function name is what we call the function. So we have a swap function. So the swap function accepts what kind of thing here? An expression, right? Before we were seeing like an expression accepting just only one variable, which is symbol or anything. But we are defining explicitly that this function is going to accept not a symbol, not a number, but an expression, right? The thing that is going to be wrapped in parentheses. So what if we say like swap accept an expression, and in the expression it should explicitly should have pair, right? Pair with one parameter x and one parameter y. So this kind of function definition is we are saying just to make it more visible. So this function called swap is expecting an expression, one expression parameter, right? This is one as one parameter, right? Since it is all wrapped in expression, so it's expecting one expression parameter, and in that expression parameter, it should have to follow such kind of definition. It should start with pair and two arguments, right? So it's expecting an expression in it, then a name called pair in it, and two parameters. Then I have to write the definition of or the body of the function, right? Then here I'm going to specify what is going to be returned. So as the name suggests, swap, I can accept a pair of things, and it's going to give me the swap of the parameters, right? Then I would say it would return pair with parameter y and parameter x, right? Here the parameter x specifies that we passed on the first parameter as first argument, right? And y is a placeholder for the next argument. Then when I swap those two, I just change the place for x and y, right? I start define y first, then I will continue to x next one. Exactly right? So let's say let's execute, right? Since we define this kind of expression, let's execute or call that function with a value. So swap would have would accept a pair of things, right? What if 1 and 2? So what would be the output of this? Is it only to 1? Exactly. So since I'm accepting, I'm defining a function called swap with parameter that explicitly is an expression, right? Which is defined in parameter. The first thing is the pair thing, and the 2 are the arguments. So then it would return the swap of those parameters, right? So let's see what is this function going to return. So if I execute this thing, so I would get what is defined in the body, right? So I have defined the swap of the arguments, so it's going to return 2 and 1 because I have passed 1 and 2, and the swap function would swap the arguments place, right? So what if I say instead of pair I say another thing like let's call it hello. So what would be the output of this definition? Hello? 1, 2, okay. What about? So you are saying that it's going to return as it is, right? But the nested expression. You are saying to this, right? So, okay, this is one guess. What about you others? Do you think, so first, do you think this thing going to reduce like this as pair to 1? Or to what thing is going to reduce?
Hello to 1.
Hello to 1. Okay. Any other guess? So I have defined a function here, right, called the swap, and swap is expecting an expression, right? But the expression has such kind of representation. It should start with pair and 2 arguments, right? So if I try to execute the function, or if I try to call the function with another expression, I'm calling another expression here, right? This expression and the above expression definition are not the same, right? The above expression is explicitly expecting to start the expression with pair and 2 arguments, but I have passed an expression that starts with hello and 2 arguments. So there is a distinct difference between pair and hello here, right? So whenever I try to call that expression, so whenever I'm trying to evaluate these things, I will see such kind of output, right? So it's returning as it is. So whenever I'm trying to execute a function or call a function, first it's going to search if there is such kind of definition in our file, right? Did I define before such kind of things? If there is no kind, if there is no any kind of definition that much to this thing, is going to return as it is, right? So this thing is an expression because it's wrapped in parentheses, huh? So I'm going to return as it is because there is no thing that's going to match. So what is missed here is pattern matching, right? So the pattern should be matched or should be the same. Here the function is expecting such kind of definitions, right? It should be an expression first thing. The second thing is thing I'm going to define on the expression is should start with the name called the pair, right? So whenever we try to match those things, it's going to fail, right? Because I say hello here, and hello and pair are not equal, right? So the pattern has mismatch here, so it's going to return as it is. So whenever you see definition that's not going to be reduced, it's going to be returned as it is, as we can see here. Is that clear? So what we call is we are passing an expression to a function, and that expression should match to the pattern that's defined or being executed up in below, right? So that is the issue. But if I say here pair is going to be reduced, right? But it also have difference between capital P and small p, right? Here. So I would get without reducing anything, right? So as it is, because camel cases also matters, right? Capital letter of the definition of symbol, it also matters. So it should be identical to the thing I have defined in the function. So it should have to start with a capital pair, then it's going to be reduced the swap of the function. Exactly right? Nice. So it should be evaluated like this. So now I'm getting the swap of the thing. Instead of you have questions? So instead of returning pair 2, what if I wanna return only the swap of the argument without pair? What am I going to change? I want the function to return as such to 1 without pair. So what am I going to change? Remove pair from where? From here? Was 1. But I'm calling this function using this kind of parameter, right, as a function. So I'm passing pair 1, 2 to the swap function, but I want that function to return only the swap of the arguments. So what am I going to change? What am I going to remove or?
Right side variable.
Exactly. So I need to modify the body of the parameter, right? Whenever I want one function to return me any specific pattern or specific definition, I'm going to modify the body of the parameter, right? Since I'm calling this function as it is, as you guys see earlier, it's going to be reduced like this, right? So whenever I'm calling a function and I want to modify what's going to be the return type, since I have showed you guys how we write a function. So whenever we define a function, we start with a function. If it accepts parameter, number of parameters, we define that, and there is a body of function, right, at the end. So we are going to change the body of the function whenever we want a specific return type or specific return output, right? So I would come here and I would modify this thing to only x and y, right? Now I'm going to get the output like this. Exactly? Yeah. So let me know if I need to repeat it. So whenever I'm trying to execute this thing, I'm getting to 1. So the function accepts pair of two things with an expression, wrapped in an expression, then I would return such kind of definition. Great. So we have seen how we define function. So what if we have different definition or pattern matchings? For example, let's say I have a function. I start with equality, then a function name called nation. So nation, and it accepts name and variable. Then it would return the name of the country. So here I'm defining simple function called nation. So it accepts the name of the country, right, as an expression for here, as you can see. So I'm expecting the parameter to have such kind of definition, right? So the first thing is it accepts an expression called name, and the second thing is its parameter, right? Parameter of anything. So a parameter of the name of the country. Then it returns the body as the name of the country is X, or the thing that's going to be passed, right? So how should I call India here? So if I want the function to return the name of the country is India, so how am I going to do it? Okay, nation. Exactly. So what is, okay, let me write. You are going to so I say India, the nation, then exactly as an expression, then I would say what? Name like this, or okay, as Camel case, right? Name India, right? So what would be the output here? Exactly. So the name of the country is India, right? So what if I change name here to different thing? What's going to be the output? Nation as it is, right? Such kind of definition doesn't exist in our definition, so it's going to return this expression as it is. Exactly. So what we are trying to do is, if we understand here, we are matching patterns, right? So the first function called name nation is expecting an expression with such kind of pattern definition, right? It has name and it has the name of the country, right? If I didn't explicitly pass that parameter as name and the name of the country, it's not going to match that pattern, right? That's what we call pattern matching. So the things that I'm passing and the thing I'm also getting should have the same pattern definition, right? So that's what we call pattern definition. So if I execute this, I would get the name of the country is India. Is that clear? Okay, nice. Very nice. This is how we define function with arguments or without an argument, with any number of arguments, right? If a function accepts 3 arguments, we have to have placeholder for or we need 3 variables name after the function definition, right? If it accepts an expression like this or like this, it should match what is defined in the expression, right? So the body of the execution, the body of the function is going to be reduced to the things that we assigned there. So this is how we define a function. So we are going to see how things are other complicated, other advanced definitions as well. So what if the last time, as we see, what if we wanna reduce some kind of arithmetic operation? For example, this definition is plus sign, right? So it's accepting 2 arguments. So as we all know, in other programming language like in Python or in C++, we are passing, we are writing things that's going to be reduced as such kind of definition, right? When we wanna define operations or arithmetic operations, we define using such kind of definition, right? We first specify the first number and the operator and the second number, right? When it comes to MeTTa, we are going to define using a prefix expression representation. What prefix means? The operation comes in first, then and the two arguments, right? Since here also we are defining functions, right? So this thing is equals to this thing. So that's what we are trying to do here. So the equality expression comes first, then the thing that we need to equate, right? So the first thing equates to the second thing. But when you see in different language, you have the first parameter here, parameter 1, then operator here, right? And operator. But when it comes to MeTTa, it's a prefix based expression. So the first thing is we define the operator, and the second thing is the two parameters, right? So when it comes to simple arithmetic operations, we also follow such kind of pattern, right? We define the operator first and the arguments later on. So if I say 2 and 3, it's going to be evaluated to 5, right? So whenever we try to define an arithmetic operation, we would define it as such, right? So if I want to write a multiplication, what I'm going to do, so I would start with the operator, right? The arithmetic operator times, then I define the two arguments, right? So I would say 4 and 7, for example. Then this thing going to be reduced to 28, right? Because 4 times 7 is 28. So I define using such prefix representation, right? So pre means the operation comes first, right? So prefix kind of representation. So I define the operation first, then the two parameters. So this is how I define arithmetic operations. So what if we want to define a function that accepts one argument and it two increments? For example, so what if you want to define a function that takes only one argument and it will return the increment of it? Increment means it just add 1, right? So it just add and returns 1. So how am I going to define such function? So you can call the function name increment, right? Doesn't matter. So then it accepts one parameter, right? Then it should return adding 1 to that parameter. That's great, all right? So can you write that, maybe? Okay. Try that out, maybe, to see if you are on the same page. So you start with defining a function with an equality sign, right? Let me give you like 30 seconds or something. Try that out, and I would know if you are on the same page or not. So you have to define a function that accepts only one argument, and it returns the increment of that function, right? So how can we define such kind of function? You guys done doing it? Is it challenging? Okay, let's do it together, and we will give you other exercises as well. So first thing is defining a function, right? So we will say function inc, or simply for increment, right? Then it accepts one parameter, right? We can say that parameter x or anything with $sign. Then it would return something in its body, right? That is incrementing or adding one into the parameter, right? So as we said earlier, it's prefix based representation. So first thing is we have to say the parameter name, right? Then one. So this means I'm passing one argument, then I'm adding one to that, I'm returning adding one to that parameter, right? If I pass, for example, 10 here, 10 here, I would get what? So I will get 11, right? So I would get 11. So this is how we define a function that accepts one parameter and do some operation on it, right? What if I want to define a function that accepts one parameter and return the square of that parameter? Are we guys on the same page, right? Is it hard? Should I repeat it? How we define a function? It is clear, right? So when we define a function, we start with a equality sign, so that whenever I get that kind of function name, it should get evaluated to something else. Then I define the function name as defined here, Then if it accepts one parameter, I would say only one x. If it accepts two parameters, I would say two parameters. Then there is a body of functions. So the thing is going to be reduced to, right? So we can define it as such. Here we have seen that an increment function, it accepts one parameter and return adding one in it, or incrementing it by one. We can also see a function that accepts one parameter as well, and it returns the square of that parameter. So how can I write such kind of function, right? Function name called the square. So it accepts one parameter and multiplication, and then two the same parameters, right? So the square of 2 means, for example, this is how the squares work, right? It accepts, for example, if we are doing the square of 2, it means we are multiplying 2 by itself, right? So I would get 4. I would get 4, right? So this is the square of a number, right? So if I want to define a function that accepts one parameter, square of x, then on the body of that function, I would say return twice of that function, that argument, right? So I would say the square of 5, it should be returned 25, right? So if I execute this one, I would get 25, right? So when I try to execute this function with 5, is going to return the square of that function, right?
So this is a simple definition of how we can define function and how we can do arithmetic operation on it, right? So we define a function in its parameter, then it returns the argument. What if we want to define a function called multiply and it accepts any kind of arguments, then it returns the multiplication of those two arguments or do such kind of operation? How can we modify this? Exactly. So how am I going to do that? So let's say let's comment this out, and so let's say function called multiply. So but how many parameters is going to accept? 2 parameters. So what and what? It doesn't matter the names, right? So we can say just x and y. X and y, then what's going to be returned is the body of the function. So the body of the function would be returning the multiplication of the parameters, right? X and y. So this function is going to return the multiplication of 2 numbers, right? So if I execute this function here, it would say 12, right? Because it executes 3 times 4, then it returns 12. I hope that's clear, right? Is that clear? Nice. Nice. So we have defined here. So any questions? Okay, but what if we want to define, or we want to do some kind of intermediate evaluation? For example, if we want to store this multiplication and we want to add some number on it. For example, the multiplication function accepts 2 arguments, right? And it returns their multiplication. Then what if I want to add a number after its their multiplication? For example, it accepts 2 numbers, multiplies them, and I want to add 5 in it after the evaluation, after the multiplication. What am I going to do? For example, it accepts 2 numbers, right? For example, it accepts x and y, then it multiplies those 2 numbers, right? After that, it's going to return adding 5 in it, right? Adding x times y plus 5, right? So how am I going to do that? What am I going to do? So what if I have a function called just t, then it accepts 2 parameters, right? X and y. Then the first thing I want to do is it should multiply both the parameters, then it should add some value in it and return. How am I going to modify that function? So could you finish the body of this definition? So we have defined a function called t, so and it accepts 2 parameters, x and y. Then after that, it should multiply x and y, then returns adding 5 in it after the multiplication. So what is going to be changed? First, it should do this kind of operation, right? Same where? Okay, multiplication the same. What about the addition or the increment? So we are doing 2 operations here, right? The first thing is multiplication and the second thing is addition. So how am I going to define such kind of operations? This is a nested expression, right? Meaning like a nested operation, meaning like first doing some operation, then later on doing another operation. How am I going to do that? First, we have to do one operation, right? Yeah. The function is going to be reduced to something else, right? So the first thing it should have to do is it should return the multiplication of x and y, right? X and y. But we want to add some number onto this multiplication, right? So we have do the first. We did the first operation by multiplying the first two numbers. Then, since the addition only accepts two arguments, this thing first must be executed first, right? So what if I did this? So I do another nested expression, and this expression would accept an addition, right? So an addition. Then the first argument of the addition is the multiplication of those numbers, right? So because this thing must be reduced first, right? Before adding some value on it, right? Then I would say the increment here plus 5. So what I'm trying to do here is first I want to execute their multiplication, right? Then later on I want to add or I want to increment that thing by 5 after the multiplication, so that whenever I pass two numbers to this function, first it multiplies both of them, then add or increment that result by 5, right? So since in MeTTa we have this prefix representation of operations, so first thing is this thing should be represented as such using a multiplication of those parameters. Then we have an operation that we are going to do, which is incrementing. Then we are incrementing it by some value. So if I execute t with function t with 2 and 3, what would be the output? 11, right? So it should be 11. So should be 11, right? So I'm getting 11, right? So when we want to do some kind of operation after another operation is done, so we have to explicitly evaluate that first thing. Then we are going to reduce that. Then we use that result to do another operation. So the first thing is this thing is going to be reduced to 6 in our case, because 2 times 3 is 6. Then after that we are adding an operation in it, right? So it would add 5 in it. So this is how we can do a nested operation. Is that clear? What if I want to do the addition of or the subtraction of the past arguments? Then I multiply it by 2. First I subtract the arguments, then I do the multiplication. What's going to be changed here? Okay. Exactly. So we have to use subtraction symbol. Exactly. Then that. Exactly. So that's how we going to do. We have a nested expression, right? So if we want to do subtraction, then after that we want a multiplication. We have to change the order of these things, right? First we have to define a function that is let's say s, then it accepts let's say parameter a and b, because they are variable name, so it doesn't matter. So it accepts a and b, then it return the multiplication of the subtraction of the two numbers, right, a and b, then with 2, for example. So this operation would return such kind of evaluation, right? So if I pass s for s 10 and 3, what would be the output? So 14, right? So I would get 14 here. So what this function does is it accepts parameters, then it will subtract first these two arguments, then it will multiply it by 2, right? So 10 minus 3 is 7, then it multiplies 7 by 3, it would get by 2, and we'd have 14, right? So these operations, plus or minus, they will reduce what is passed to them, right? They didn't like just use this thing as it is. They first reduce the parameter is going to be passed, then it will add the next number or multiply the next number, right? So this is how we do it if we have a nested expression. Let's make it a little bit advanced. So what if I passed s with such kind of operation, and let's make it 2 and 3. So what I'm trying to do here is I have a function called s, right? I think I have defined here. So for s, I'm passing how many arguments? Only one argument? Two arguments, right? After the name of s, there is two things, right? But they are different. What's the first thing? It's an expression, right? An expression which is being represented as an addition of two numbers, right? 2 and 2. And the second argument is 3. So what is the value of b? The value of b, or the value of the b argument, is 3, right? What about the value of a? Right. So what I'm trying to show you here is whenever we define an expression with some kind of evaluation, it first evaluate the argument or the parameter, right? So it first evaluates the parameter of the function, then it would assign the reduced version of that. So we call it reduce, right? So this addition representation will be first reduced to some value, then after that is going to be passed to a function, right? So here we are defining an addition function or an addition expression. So first we evaluate this thing before we pass to s, right? Then after these operations, the value of a, or the variable of a, would have an expression which is 4, right? And the variable b would have an expression 3. Exactly, right? So before passing to a function, everything is going to be reduced. So that is one power in MeTTa. So before we pass anything to a parameter, those parameters going to be reduced as much as they can, right? Then those reduced values is going to be passed to that parameter. Then the other operation, it continues to be evaluated. So if we execute this thing, we will get what? So first, our parameters are 4 and 3. So we will get 4 minus 3 first, right? Then we'll have a result of 1. Then we multiply 1 by 2. So it's going to be 2, right? I didn't execute this one, right? I just define it. I need to start with this exclamation mark, right? If I don't have, if I don't define exclamation mark, just treat it as definition in the space, right? It's not going to be executed. So if we need to execute anything, don't have to miss the expression. So as we expected, we have such kind of output, right? So the thing that we are seeing here is called higher order functions. So what means is that a function can accept other function as an argument, not a reduced value only, right? This thing is not reduced here, right? It gets evaluated before it gets passed to the function, right? So if I define another function as well, first that function do its operation on that argument, then it returns the output or the result, then that result is going to be passed to the function that's defined previously, right? Let me show you what I mean by higher order function. So we have s right here. We define s here. So what if I say, what if I have a function called we have a function called increment, right? So let's say let's execute this thing as such. So we have we define a function s. That the first parameter would be a simple parameter, as like, for example, if we are passing 5, and the second argument would be, what if it will be an increment function? Increment function. So this increment function accepts 4. So we need to define an increment function. So we have defined or implemented here. So we have seen how we define increment function earlier, right? To accept one number and add 1 in it, right? That's what increment function does. So so here we are passing another function as an argument for the later function, right? For s, I'm passing a function called increment, right? As you can see here. It's clear, right? So s always accepts 2 parameters as based on our definition, parameter a and parameter b. Yeah, please. And as you can see here, the first thing is a number. That's one argument, right? But the second argument is another function, right? Function called increment. So when we say function are higher order functions, higher order means they don't only accept just simple parameters. They can accept another function as a parameter as well. And before that operations or that function get executed, is going to reduce the result of that function. Then it will assign variable to that function. So based on this definition, let's first see the output. So what it does is, so we passed 4. So the first argument, what's the first argument here? Comment the first argument, which is a, is 5, right? 5. What about the second argument, which is b? So b is it's a function, right? So yeah. Okay. What about now? Nice. So our parameter, the first parameter is already a number or a grounded, so it's going to be assigned as it is to a. But when it comes to the second parameter, which is b, so our function definition is accepts 2 parameters, a and b, and the first thing is grounded, so 5 is not going to be reduced to anything. We just assign 5 to 5, right? 5 to a. Then when it comes to the second parameter, we are passing it as function here. So that function accepts one number and do increment on it or do addition on it. So as we see earlier, this increment function accepts one parameter or one number, then it's add 1 or it do the increment, right? So this is a function. So whenever we are passing argument for a function, another function for function. We call it like higher order functions because they accept not only reduced values but also other functions as parameter, right? We don't see such kind of feature in other programming language. So we can pass a complex argument here, then this function do its computation or do its multiplication or anything or any operation on it, then it will return some value, then that value is going to be passed to the argument, right? So b would have value of what? Value of what? Increment of which is increment of 4, which is 5, right? So first 4 would be increment will do his operation, which is adding 1 to 4, then it will reduce to 5, right? Then this above definition is the same as such definition, right? So these both are the same because the increment operation do adding 1 to the argument, so we did pass 5, so we can say S55, then we will get the same result as well, right? Because the subtraction will return 0, so multiplication of 0 to any number is 0, right? So we call it this as higher order function. So higher order function. So when we define function, we can also pass another function as an argument to that function. Then the first function will reduce that definition, then it will return the reduced version of it, right? So these operations are the same. So first we have passed 5 here, then we do the increment also to 4, then it's going to be 5. Yeah. Then first thing is this thing is going to be reduced, which is subtraction of a and b. So a is 5, b is also 5. Then after that we do the multiplication, then 0 times 2 is 0, right? So this is how we can do such kind of definitions. So we can define a higher order function as well. So I guess we have time to continue to other topics as well. So what if we want to define a function that accepts other function as parameter as well? For example, like the previous one, now we can say function S would accept, when we define a function, we start with an equality sign, then 2 parameters as well. So the first thing is function name, for those of you who come late. So then the first thing is defining the function name. So we have a function called S. Then we are going to pass this function. So we have this, we have seen this square function. So square function, square function accepts 1 argument and it returns the square of that function, right? So square here accepts a number x or any number, then it would evaluate it to the square of that number, right? So since in MeTTa we have seen that it's prefix based language, so that means we have 1 parameter and 2 parameters, and we have to define the operation as prefix of, which means like pre from the parameters, right? In other language or in Python or C++, we say like 2 plus 3, right? But when it comes to MeTTa, the operation comes first and the arguments. So this square function accepts 1 argument and it returns the square of that number. So if we pass, for example, 2 for this, so if we pass 3 for square, then it's going to be evaluated to 9, right? Because 3 times 3 is 9. So whenever we pass a function to parameter to this function is going to be reduced as such. So yeah, so so we have this s function called s, which accepts two parameters. That first it subtracts those two parameters and multiply it by 2. It is a simple mathematical operation. So s accepts two numbers. For example, we pass like 3 and 2, for example, to these functions. If we pass as such, for example, s with 3 and 2, first a would have a value of 2 and b a would have a value of 3 and b would have a value of 2. Then first it do the subtraction, right? Because this thing need to be reduced. So it would accept 3 and 2, then it will do the subtraction, right? So it will subtract 2 from 3. This means it will evaluate to 2. It will evaluate to 1. Then after that we multiply that result by 2 and we return that. So this operation would return a value of what? 2, right? Because their subtraction is 1, and when we multiply 1, this result comes to 1. When we multiply this by 2, it would get 2, right? So what if we passed other function here as well? So we want to find is that is square of 3 and increment of 3. So what would be the result here? So I'm passing 2 parameters to the function called s, right? We have defined the function s here. So we have a function s here. So it accepts only 2 arguments, so a and b. But I'm passing other functions into this as a parameter, right? So what would be the result? 10. Okay. Why is that?
Square of 3 is 9.
Exactly.
Incrementing 3 will be 4.
4, exactly.
9 minus 4, 5.
Exactly. Then we multiply that result with 2, right? Yeah. Do you guys understand? Right? So as we said earlier, before we pass any argument to a function, that argument is going to be reduced, right? So since we are passing function as an argument with some kind of value, for example, on this definition, we are passing 3 to the square, to the function called the square, that accepts a number and it would evaluate it to the square of that number, right? So for 3, it's going to be evaluated to 9, right? So here, before passing to function s here, our parameter is going to be reduced, right? So our parameters a would have a value of what? Value of what? A would be 9, right? Okay. Then what about b? 4, right? Because an increment function accepts a number and it will just increment it by 1, or it's add 1 on the parameter. So the function b, the parameter b would be 4, right? So the operation would be such kind of operation. So first we do the subtraction here. So we do 9 minus 4 because our a is 9 and the parameter b is 4, right? Then we would evaluate it to 10 after multiplying it by 2. Is that clear? So for functions, we can also pass other functions as an argument, right? So this is what we call higher order functions. So we will see it in more complex operations, but functions can accept other functions which are not reduced. Before they being passed to us an argument to a function, they do their computation, their operation on it. So this function can be a complex one. We have seen just simple example. So that accept a number and give a square of it. But this function can be a complex one, right? It accepts any number of parameters, any operations, then it will do its computation, that it would return the reduced form of that function or the result. Then using that result, we continue to the operation of this function or the function s. Is that clear, right? Are we on the same page? Nice. So we can also define such kind of operation. Very nice. So what if so here our function we define here has sequence of operation, right? So the first thing is it does this operation, right? Which is one operation, doing it like doing subtraction on the parameters. Then using that result, we are going to also increment that value, right? So instead of defining such kind of complex operations, we have a built-in function called late that I'm going to show you, so that it would always store the intermediate values, right? This thing is an intermediate value, right? We are not returning these things, or we are not doing operation on this thing, right? We are like first execute this operation, then after that this is an intermediate value, then after that we multiply or do another operation with it, right? So not to make it too much complex, we have function called, or a built-in function called late. As the name suggests, late would accept 3 parameters. So would accept 3 parameters. So as you can see, you guys, it's being highlighted by the syntax, right? So it has a different color. So this means that late is a built-in function. So late would accept 3 arguments. The first thing is the name of the variable or the placeholder. We call it, we can say like variable name, and then the second thing is what kind of operation, what is the intermediate operation it is, and this is intermediate operation. So then the third one would be the return type, right? Return type or output, you can say output. So it kind of accepts such kind of argument. So it accepts the variable name or placeholder, intermediate value, then an output. So let's see what it means with an example. So what if we have late variable name a would store the square of, since we have the square operator function here, right? So the square of 3, then it returns x. It returns a, right? So this late is a built-in function that helps us to store intermediate values onto some other variable. Then using that variable, we can continue other operations, right? Which is output or the return type of that function. For example, if I execute this one, so I would get 9. So what is late doing here? It's help us to compute like the intermediate values or the intermediate operations. So we have a square of 3 here as an intermediate operation. Then we want to store this operation into a variable called a. So when we call square with 3, it's going to return 9, right? Then I'm going to store that in variable called a. So a would have a value of what? 9. Then after that, there is an output of the function. The output of the function is just returning itself. But what if I can do a complex operation on it? So storing it into the intermediate value or intermediate variable really help us to continue to do other operations as well. For example, I can do the increment on a, right? Variable a by 1. So I would get 10. So these operations somehow do the same operation, but it's kind of complex, right? When we have a lot of operations or a lot of nested evaluations, we are going to represent it as such, and it becomes very complicated, right? But we have this late built-in function that it accepts the first argument. It accepts 3 arguments. The first one is placeholder or variable name that we are going to assign. Then there is an intermediate evaluation or intermediate operation or intermediate function that we are going to do on it. Then the last argument is an output, right? So for late here, I have defined variable name, which is a, and it accepts intermediate operation or a function called square, and it calls that function and do some operation on it, and it returns that operation, right? Then we store that operation into a variable called a, so that whenever we try to access a from now on, it would have the result of that intermediate operation, right? So what if I want to define the increment function, right? So first I'm going to call the increment function, do some operation on it, and I'm going to return the increment after squaring it, right? For example, first I'm going to increment a number, then return square of that number, right? So what am I going to do here? So the first operation is doing an increment of some number, right? So we are going to increment a number, then after that we are going to return the square of that number, right? How are you going to do it with late? So as we said earlier, late would have 3 arguments, right? What's the first argument? Variable name, exactly. So the placeholder, which is a variable name, which is, we can say like x here. We use x as a parameter. Then we have intermediate operation, right? What is that?
Increment function.
Increment function, exactly. So the increment function would accept numbers, and we can say, for example, 5 here, right? An increment function, as we said earlier, would accept one number and it incremented by 1. Then after that is going to what? To do what?
Square function.
A square function. So since we are like doing a nested operation or a sequence of operation, right? We have one operation first of all, then after evaluating or reducing that expression, we are continuing to another operation, right? So I'm going to define square here, right? Square of what? X, right? So I'm storing the intermediate value of one expression into one function into a variable name that I defined here called x. Then I have another function, right? On the output one, since we have an output, the last argument is an output in late, so the output would be the evaluation of this thing, right? So what's going to be x would be?
So you need to give a dollar F5 increment function.
Yeah.
They're giving 5. Is that correct?
So what the increment function does?
This should increment x, right? Then this should score the x.
So here there is a sequence of operations. So before assigning any value to x, we are going to evaluate the intermediate function, right? The intermediate function here is increment 5. So what does the increment 5 does?
If
So
you
we
increment 1 to 5, then you get 6.
exactly. So the function increment would accept one number, and it returns and incrementing it by 1, or adding 1 to that parameter, right? So it's going to return, since we passed 5, it's going to be reduced to what? 6, right? Because we call increment with 5, then x it would be 5 here, then we are adding 1 to it, right? So here when it comes to this variable, x would have what? Would have value of what? 6, right? So x would have a value of 6 because we have this an intermediate function or intermediate evaluation, right? So after this evaluation, we pass that result to another variable called x. Then using this variable definition, we are going to do some operation on it, right? Which is that passing it to a function called the square. So x would be here, would be what? What's the value of x? 6, right? So x would have a value of what? 6, because we are calling late. So late first call this intermediate operation, then it assigns the value to this variable x, then it returns the things that we define here. So this thing is going to be reduced or being executed, right? So since x is 6 now, we are passing 6 to square, function called square, right? Then is going to return what? What would be the result? 36. So if I run MeTTa and the file name, I would get what? 36 here. This thing is also being executed. Let's comment this out. So I would get 36, right? So is it late clear? So when we are trying to do operation on late, so we have keyword starting with late, then it has 3 parameters. The first thing is the variable name, or the variable that's going to store the intermediate operation. So that after that operation does what it does, then it store on variable name. After that is going to be returned what is we are defining the output, right? So what if I say such operation, let let's say y be increment of 6 or 9, doesn't matter, and I define 4. So what would be the output of this definition? What's going to be returned?
4.
Why 4?
That parameter just prints.
Yeah, exactly. So we are storing an intermediate value in y, right? Which is incrementing of 10, or incrementing of 9, which is 10, right? So y is 10. But the last parameter, as we see here in late definition, is output, right? We are not doing anything to y. So we don't care about what this function does, right? So late would return, which is 4. So we are not doing anything on the value of y. So if we execute this thing, we will get 4, right? Because we are not returning y, or we are not doing anything in y, right? So that the last argument is always the output. So if you want to do some operation into the intermediate variable, we are going to also specify here on the output, right? If I say increment of y, what would be the result of y? What would be the result now? What? 11, right? Because we are calling increment into the intermediate value. So if I execute it, I would get 11, right? So I'm assigning the result of the first increment into y, then I'm calling another increment into that intermediate value. So whenever we have such kind of nested operations, we are going to use late, right? So using late, if you have a sequence of operation and we have some intermediate operations in the middle, we are going to assign that into a placeholder called y, and we are returning that. So what if I want to do sequence of 3 operations? So here we are seeing sequence of 2 operations, right? Doing 1 operation, then we return evaluating that expression, right? For example, here we have only 2 sequences. First, we are adding 1 number to 5, then after that we are doing these operations. These are only 2 operations, right? We are adding something, then we are squaring that number. What if we have like 3 or 4 nested expressions? What are we going to do?
Nested left, you can have nested left in the intermediate value.
Exactly. So we can also, before returning the output here, right? Before returning an output here, we can also do another nested operation here, right? Since we have, what if we want to do such kind of thing? First, we square a number. So the first operation is square a number, which is n. Then we have one operation, and the second operation is we are going to increment n. We are going to increment the result that we get from square of a number. Then we say let's say y. Then the third operation is to square that number again, which is a result of the increment of the square of a number. Let's call it z. So we have such kind of 3 nested expression, right? So the first thing we are going to do is we are going to do a square on a number. Then we are going to increment the result of the square. Then after the result of the increment, we are going to square that number again. So we are doing nested 3 operations, right? Here. So it has 3 steps. So how can we define this with late? How can we do these operations? Yeah. My AI is suggesting like that. So how can we do that?
First, let me create a let.
Okay, we create a late.
On an intermediate value, we create next let.
Okay.
Then we square the n value.
Okay.
Is there any possible way to cancel out the third argument in the function?
If the function expects an argument, you should have to pass that argument, right?
Yeah.
So since late is expecting 3 arguments here, as we define here, so it should always follow such kind of pattern, right? Unless if this pattern is not satisfied, we'll get like an argument error. For example, if I do late 1 x is an increment of 3, then I didn't define the return type, right, the output. So I would get an argument here, as you can see, incorrect number of arguments, because late expect 3 arguments, right? The variable, the intermediate operation, and the output. I didn't define the output type here, so it's going to say an error. It's going to throw an error. This kind of definition have this incorrect number of arguments. So I need to define that. Yeah.
So, the inner let, right? If it gets printed out, we get printed output, right? Output.
Yeah.
Is the output is assigned to the first outer let variable?
Late for solving this equation.
Yes.
Okay. Yeah. So since we have this output option here, as we have seen here on the previous example, we were getting like we are returning 4, right? Without considering the value of y, right? So we can specify what is going to be returned as output here, right? So using this output, we can also nest other expressions. So instead of returning just the operation or the intermediate value, we can also nest other operation as well. So let me show you what I mean. So since we have late here with 3 parameters, right? the first thing is a variable name, right? So the variable name is, we can't say anything to it. Let's say it A. Then the first operation is squaring a number, right? We can say that square of what? 5. N is any number, so we have a square of a number. So we have filled the two arguments, right? So we have the output argument. Then in the output argument, we can specify what kind of thing is going to be returned, right? So are we going to do only this operation? If I say, for example, increment of y, I would get, increment of a, which a is a variable that I have assigned here. So the result will be what? Yeah, 36 because 26, because the square of 5 is 25, and I assign 25 to a, then I am adding 1 to a, which is, it becomes 26, right? It's not evaluating anything. What about the third option? We didn't define it, right? So we want to store the increment 26, and we want to pass 26 to square, right, as a parameter to the square function. So which is sequence of operation. So here I'm going to do what? The output, right? On the output part, I want to do another operation as well. So I can define another let here, right? Another let here with the same arguments, right? It accepts 3 arguments. So the first argument is a variable name, and the second is the intermediate value as well, and the last one is the return type. Then after the first let knows that to return this thing, right? The first let only knows to execute square of 5, then it assigned to a, then it returns this value. But this return has another let on it, right? So it can do a nested operation, right? So I can say the next variable is b. I can define anything. Then what is the second operation from our equation? What's the second operation? What is this? Incrementing, right? Incrementing the result of the square. So what should I say here? Increment of what? Which variable, a or b? A, right? Because a is the one that stores the result of the square of 5, right? So a. So what would be the value of b now? What will be the result of b? 26, right? You guys understand? Yeah, because the first thing is squaring 5, and after evaluating that, I'm going to assign that value to a. So a would have a value of what? 25, right? Because the square of 5 is 25. Then on the return type, I came here and define another let operation, nested let operation. So in the output section, I would have variable b to store an intermediate value, which is the increment of a. So now our let function knows that what is a, the value of a, because it has been evaluated before here, right? So it has been evaluated to what? 25. So increment of 25 would be passed to the increment function. Then b would have what? A value of 26. So we have completed these 2 operations, sequence of operation, right? Then after that, we are going to return something. So what are we going to return? What's the return type? What are we going to return? Square of b, right? So since we store b here, so a square of b, which is large number, right? So our operation, what we are doing here is we have the first let with 3 arguments. Anything that's wrapped into an expression is treated as 1, right? So this thing is as an output. So we have a square function with a number passed to it. Then we are going to store that intermediate value into variable a. Then after that, when it comes to the return type, it has an nested let. Then the nested let would execute first the increment of a number, then after that it would store it into a variable called b. Then after storing it in b, it would return what? The square of b. So if we execute this argument, we'll get a large number which is 676. So the result of which is the square of this means the square of 26, right? The square of 26, which is 26 times 26. So that's why we get 676. So this is how we can do a nested expression if it has three sequence of operations, right? The first thing is, yeah, is there a question? So the first thing is doing a square to number, then we increment it by 1. So these functions are defined here. So we have to also make sure that these functions are working, right? Unless it will get like it's not going to be reduced, right? Because this function is not defined. So we do an increment of the second operation, then on the third operation we do the square of those intermediate values. So we have two intermediate operations, right? The first thing is the square, and the second is the increment operation. Then after that we have the square. So this is how we can do nested operations. So this is how we can execute intermediate values. So what if we have like fourth operations then? How are you going to do it? Right? After that, I'm repeating these operations. So I'm trying to, the first one is incrementing the result. So what would be the result here? So incrementing this 676, right? So the result of this operation would be result to what? 677, right? How am I going to write functions that do such kind of nested operations then?
We have inner net.
Okay, yeah, you are right. So as we said earlier, since we grow from 2 to 3, we add another operation late here. So where are we going to add another late here?
Inner net.
Exactly. So instead of returning the square, we are going to add another late, right? So what if you have another like fifth operations then? So this thing is going to grow like by adding late, right? And the expression, the definition is going to grow like this, right? But to overcome such challenges, we have another built-in function called late star. So as you guys can see, this is thing also get some kind of highlight because it's a built-in function. So we have another late star definition. So since the operation is going to grow as such, and one expression should have to wait the intermediate of the another operation, then we use that operation. So when we are trying to do these 4 operations, we are going to have a nested late, right? Late. We're going to have nested late. Then after for example, if we have the fifth expression, the fifth operations, we are going to define another for the late, right? So to overcome that, we have late start definition, so which is going to help us how we can define a nested operation, so that we don't have to say late again if you have a nested expression, right? So we are going to see how we can write late. Is it everything clear now until now? How we define a function, how we can pass other function as an argument to another function, and also how we can do a nested operation or sequence of operations. So these are the things that we have seen from the previous, continuing to the previous sessions. So I would like to give the latest star problem for you guys, just to make you curious how we can solve a nested expression using a latest star operation. So since we have a lot of expressions or a lot of evaluations in the middle of this evaluation, how can we represent that using latest star? We are going to maybe see it on the coming sessions and also other evaluations as well. Are we on the same page until now? Right? Yeah, so should we continue? Yeah. Okay. So is there any question? Does anyone have a question? Because we are going to see some more complex operations next on, how we can define recursions and the things that I have covered as well, like using latest star for nested operations. What if we want to define functions that have some kind of recursion? For example, I want to define functions that find lengths of a list, right? How am I going to define recursive functions? And we are going to see also controls on the next sessions, because we don't have a lot of time for today. So I would like to give you as an exercise to do such operation using latest star, and we are going to see it on the coming sections. Maybe you can also try it on tomorrow, and we can also see it there. So as exercise, try to implement a function that does such kind of operation. So it first accepts the first number and increment it, then square it, then it should return the increment at the last. So how can we represent using this as using late star, which is an extension to late, right? So we have late star. How can we define functions that can do such kind of nested operation? And later on we will also see how we can implement functions that find recursion. So that finds the length of a string or an array. So an array, which is recursion definition, and other also recursion operations. And we will see a control flow also. So yeah, this would be the next sessions. Is there any questions? Any question from you guys? Am I going fast? That's good. So by the end of this session, you have to know how to write a function that do any kind of operation. It can do mathematical operation or arithmetic operation, what we call, and how we can also define a function using such kind of structure or such kind of representation, using function name, starting with equality, then a function name, then number of, if it accepts a number of parameters, we will specify a number of parameters here. Then we will have a body of the function that's going to be returned. This is how we are going to define function. We have seen how to define simple function like duplicate, square, and increments. Then we also see how we can pass other function to as a parameter to function, which is we call higher order functions. Then we also see how we can do simple operation as well. So you guys should have to try how to represent such kind of operation using late star, and you can do also some research, or we can also see how we can define